Hey kids, welcome to section 4.1, Operations with Polynomials. Today you're going to learn how to multiply, divide, and simplify monomials and expressions involving powers, and you're going to learn how to add, subtract, and multiply polynomials. So first thing we need to do is review some of the exponent rules that you learned about in Algebra 1. To simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. And these negative exponents are just a way to express the inverse, the multiplicative inverse of a number. Now, here are all the major exponent rules. The first one we have is product of powers. And this one says that if you're multiplying two monomials together and they have the same base, that you're allowed to add the exponents. So for instance, p to the second times p to the ninth, you add the 2 and 9 together to get 11. The second exponent rule is called the quotient of powers. By the way, it's not necessary that you memorize the name of the rule, just how to use it. So quotient of powers says that if you have x to the a divided by x to the b, that you can subtract their exponents and get x to the a minus b. So when you're trying to simplify and you have the same base, you subtract the exponents. So b to the sixth over b to the fourth, you would subtract the 6 minus 4 to get b squared. The third rule is the negative exponent rule. The negative exponent rule says basically that if you have any letter or number to a negative power, that you can do the multiplicative inverse, which means you find the reciprocal, and then the power becomes positive. So if the negative power starts on the top of the fraction, you put it in the bottom of the fraction. If the negative power starts in the bottom of the fraction, you're going to move it to the top of the fraction. So for instance, 3 to the negative fifth is 1 over 3 to the fifth, and 1 over b to the negative 7 is b to the positive 7. So you simply take the reciprocal. The next rule is called power of a power. It says that if you have some power, x to the a, and you're taking the whole thing to the b power, that you would multiply the exponents, x to the a times b. So for instance, if I have d squared to the fourth power, I would multiply the 2 and the 4 to get d to the eighth power. The next rule is called the power of a product. This one says that if you have a product that you are taking to a power, that you would share the power to everything in the parentheses. So x, y, quantity to the a power, I would share and get x to the a and y to the a. So if I have a, b to the third power, I would do a to the third, b to the third. It also works with numbers. If you have a number and a letter inside of a parentheses, all to a power, you can share the power to the number and to the letter. The next property is called the power of a quotient. It says that if you have some quantity divided and taking it to a power, that you distribute the power, x to the a, y to the a. If you have a quotient to a negative power, the first thing you should do is make the power be positive and take the reciprocal of the quantity inside. And then you can use previous rules to simplify. The last rule is called the zero power. It says any letter to the zero power is 1, and also any number to the zero power is 1. These rules are going to be the difference between you understanding and not understanding all the little bits of this lesson. So know those rules. If we want to multiply and divide monomials, we need to recall that a monomial is a number, a variable, or an expression that is the product of one or more variables with non-negative integer exponents. Make sure that when you're simplifying a monomial that you check 4 things to make sure that it's simplified fully. You cannot have any powers of powers. You have to make sure that each base or each letter appears only once. You need to make sure that all your fractions are in simplest forms, and then make sure that there are no negative exponents. As long as you can clear all of those, you've simplified the monomial. All right, example number 1, simplify expressions. Assume that no variable equals 0. Okay, if we're looking at letter A, I can multiply the numbers with the numbers. So 2 times -7 is -14. Then I can simplify and multiply my x's. So x to the -3 and x to the 5th, I can multiply. And when I multiply, I add the exponents. So -3 plus 5. And then with the y's, I have y to the 3rd minus 6. So if I simplify this, it gives me -14, x to the 2nd, y to the -3rd. Oh, but we're not done because we can't leave negative exponents. So what we're going to do is we're going to make a fraction. We're going to keep the -14 on top because only negative exponents swap positions, not negative values or negative coefficients. I'm going to leave the x squared on the top, and I'm going to move the y to the bottom and make its power 3. Okay, letter B, notice I have numbers, C's and D's. So first I'm going to do the numbers. If I just look at 15 over -3, 15 divided by -3 is a -5. Then I'm going to look at my C's. Since I have a C on the top and a C on the bottom, I subtract their exponents, 5 minus 2. And then I have D's on the top and D's on the bottom, so I do D to the 3 minus 7. Always the top minus the bottom. This gives me -5, C to the 3rd, D to the -4th. And I can't leave negative exponents, so I'm going to put a fraction. The -5 is going to stay on top. The C cubed is going to stay on top, but the D is going to go down to the bottom, and it's going to become positive. So -5 C cubed over D to the 4th. Okay, letter C. Anytime you have a quotient to a negative power, the first thing I recommend you do is find the reciprocal of the inside and change it to a positive power. Then you can share the power to the quotient. Everything inside gets a 3. And then I can simplify one more time. 4 to the 3rd power is 64 over a cubed. All right, finally, letter D. I have a product to a power, so I have to share. So I'm going to do -2 to the 5th. I'm going to do x cubed to the 5th. And I'm going to do y squared to the 5th. So -2 to the 5th is -32. I'm going to multiply these powers to get 15. And I'm going to multiply y powers to get y to the 10th. So -32x to the 15th, y to the 10th. Okay. Next, we have to look at whether we can add, subtract, multiply, and divide all these different monomials together, put them into polynomials, and then perform all sorts of operations with them. One thing to know, in addition to what a monomial is how to find the degree of a polynomial. The degree of a polynomial is the degree of the monomial with the greatest degree. So for instance, if I want to see if these expressions are polynomials or not, I first have to check and see if each piece of the polynomial or potential polynomial is a monomial. Remember, if you have a monomial, the definition again was a number, a variable, or an expression that is the product of one or more variables with non-negative integer exponents. So it can be numbers, letters, or numbers and letters multiplied together, more than one letter, can't have any negative exponents. So if I take a look at letter A, 1/4 x to the 4th y cubed is a monomial. 8x to the 5th is a monomial. So therefore, this is a polynomial. Yes, a polynomial. Then it says, if it is a polynomial, state the degree. Okay, so to find the degree, it says that you find the degree of each monomial, and the biggest one wins. So for instance, this first monomial, the degree is 7. The next monomial, the degree is 5. 7 is bigger than 5, so the degree is 7. If we look at letter B, square root x plus 4. Well, square root x has a radical in it, and that's not allowed. Technically, you're going to learn more about radicals later, but the square root of x is the same as x to the 1/2 power. Now, that's not an integer exponent. So therefore, this is not a polynomial. We can say because the radical with the x. And maybe we'll just kind of circle in the question what makes it not. Okay, if we look at letter C, x to the negative third plus 2x to the negative 2 plus 6, we need to check and see if each of these things are monomials. Well, x to the negative 3 is not a monomial because you cannot have negative exponents. So right away, this whole thing is not a polynomial. Because exponents are negative. So we'll circle this guy and we'll circle this guy. All right, letter C, x divided by y plus 3x squared. Well, we now know that x divided by y is the same as xy to the negative 1. That has a negative exponent, so this is not a polynomial. Because the exponent is negative. Okay, and then finally, letter E, x to the 5th y plus 9x to the 4th y cubed minus 2xy. Well, x to the 5th y is a monomial. 9x to the 4th y cubed is a monomial. And negative 2xy is a monomial. Therefore, this is a polynomial. Yes, a polynomial. I need to find the degree. And it's the monomial with the highest degree. So this first monomial has a degree of 6. 5 plus 1 is 6. This monomial has a degree of 4 plus 3 is 7. And this monomial has a degree of 1 plus 1 is 2. 7 is the biggest number, so 7 is the degree. All right, so now that we've established what is and is not a polynomial, we can add and subtract polynomials. So the directions say to simplify each expression. When you simplify expressions, you're looking for like terms. So find those like terms. You also want to put things in descending order. Descending order means that you have the highest, you have the degrees of the polynomial are going in descending or down order. So start with your x squareds, then do your x's, then do your constants. So if we look at letter A, I have 4x squared minus 2x squared. That's 2x squared. I have negative 5x minus 3x. That's negative 8x. And 6 minus a negative 1 is 7. Notice it's in descending order. I have the squared term first, then the x to the first, then the constant. Okay, in letter B, it looks like we're adding. So we're going to find like terms. 6x squared plus negative 4x squared, that's 2x squared. Negative 7x plus 9x, that's 2x. And 8 plus a negative 5 is 3. Descending order, good to go. Okay, if we look at letter C, we are subtracting. So I've got negative x squared minus x squared. That's negative 2x squared. Then I have negative 3x minus 2x. That's negative 5x. Then I have 4 minus 5. That's a negative 1. And then finally, we're subtracting again. So I'm going to find like terms. Notice there is no x squared in the second polynomial, so therefore there's nothing to combine with the first 3x squared. Then descending order says I subtract a negative x, which is a plus x. And then I can put negative 6 minus 1 and get negative 7. Okay, well, we can do some multiplying now. These directions say to simplify by using the distributive property. Notice in each of these examples, you have a polynomial inside of the parentheses and some monomial on the outside of the parentheses. To multiply a monomial by a polynomial, you distribute. So you take what's outside and you're going to multiply it by everything on the inside. So we've got 4/3 x squared times 6x squared plus 4/3 x squared times 9x minus 4/3 x squared times 12. So now we simplify. 4/3 times 6/1 is 24/3, which is 8. X to the 4th power, because we add, plus 4/3 times 9/1 is 12. X to the 3rd power, 2 plus 1 is 3, minus 4/3 times 12/1 is 16, x squared. And I don't have any more like terms. X to the 4th, x cubed, and x squared are all different powers of x, so therefore I am done. Okay, if we look at letter B, I'm going to do the same thing. Distribute what's outside to everything that is inside. So I'm going to have negative 2a times a negative 3a squared minus a negative 2a times 11a plus a negative 2a times 20. This is going to give me 6a to the 3rd. Then we have negative 22, but minus a negative 22, so that's a plus 22a squared. And then I have a negative 40a. No like terms, so I'm done. Okay, in letter C, again, we're going to distribute to everything inside of the parentheses. So 3x times 2x squared minus 3x times 4x plus 3x times 6. So this is going to give us 6x to the 3rd, because we add 1 and 2 to make 3, minus 3 times 4 is 12, x to the 2nd, because 1 plus 1 is 2, plus 18x. No like terms. I'm good to go. All right, there's a lot going in letter D. We're going to take that negative 2/5 xy squared and we're going to multiply it by everything inside. Okay. And if you don't want to write this out every time, that's your choice. A lot of people, it helps to write it every time, because then they don't make silly mistakes as much. Okay, if we want to, we can multiply. So we get negative 2/5 x to the, well, we have x to the 1st and x to the 1st, so that's x second. And then I have y to the 2nd, y to the 1st, that's y cubed. Then I multiply, and a negative times a negative, that's a positive. 2/5 and a half. When I multiply, I get 1/5. X to the 1 plus 1 is 2, y squared. Minus, then I have 2/5 x, and then y to the 2 plus 5 are 7. Now none of these are like terms. X squared, y cubed, x squared y squared, and xy to the 7th are all different. So I'm done. Okay, and finally, what if we have to multiply a polynomial with a binomial? So remember on the previous slide, we only multiplied the polynomial by x or by -4, but never together. Well, when we multiply polynomials by binomials, we again need to distribute. So we're going to take the x squared and we're going to multiply it by x, and then we're going to take the x squared and multiply it by -4. So x squared times x is x to the third. X squared times -4 is -4x squared. Then we're going to take the 4x and multiply by x, and the 4x and multiply by -4. So 4x times x is 4x squared. 4x times -4 is -16x. Then I'm going to take the 16 and multiply by x, and the 16 and multiply by -4. So plus 16x, and 16 times -4 is -64. So then I'm going to combine like terms. And descending order, don't forget. So I see x to the third, it's the only one. Then notice -4x squared plus 4x squared, those add to 0. And -16x plus 16x, those add to 0. So we have just the -64 left. By the way, this is called the difference of two cubes, and you're going to learn how to factor back to the original problem later on in the chapter. Okay, letter B. Again, we have a polynomial and a binomial. So we're going to take 2x squared, multiply it to both of the things in the second parenthesis. So 2x squared times 3x is 6x cubed. 2x squared times -1 is -2x squared. Then I'm going to take the -4x and multiply it to both things. So -4x times 3x is -12x squared. -4x times -1 is plus 4x. And then I'm going to take the 5 and multiply it by both things in parentheses. So 5 times 3x is 15x. And 5 times -1 is -5. Now we're going to collect like terms and put them in descending order. So that's 6x cubed. Then I have -2x squared minus 12x squared. That's -14x squared. Then I got plus 4x plus 15x. That's plus 19x. And a -5. All right, kids, that's section 4.1. If you guys have any questions, please let me know. And as always, keep calm and keep trucking.